Caching is a great idea. It's kind of across the board, a nifty thing that you can enable on your network, right? You may be familiar with caching servers from OS X Server. That's a very popular thing to put out there now because it holds iOS and macOS software downloads or personal iCloud data so that the devices on your network don't have to re-download those updates and that personal iCloud data from servers on the internet once they've already been downloaded once. This is really helpful whenever you've got a lot of those devices because it saves bandwidth. Another kind of caching server is known as a proxy server. The way that works is when a client system goes to a website through the proxy server, the images and movies and data that comprises the web page they've requested comes through the proxy server, but the proxy server holds on to all that stuff locally. And just in case someone else goes to the same web page and they need to reload that same data, proxy server holds on to it and can pass those images and larger files off to the other client as well. This makes the download process a lot faster, but it also saves the bandwidth required to download identical data over and over again. And that's the concept that is really shared here with a local DNS server, because DNS has a similar concept that really helps the performance of DNS response time on your network when clients are requesting DNS information that can be found on the internet. Now, when you get into a web browser and request www.apple.com, for example, your browser sends out a request through the DNS resolver that's built into your operating system. Okay, now that resolver contacts the DNS servers that you have configured in your network settings for it to contact on the system, whatever device you're using. Now, that DNS server, also called a name server, then checks to see if it's already got the answer to the query in zones that it has configured locally, or if it has the answer cached from a previous request. Now, assuming it's a request for previously unknown data, it's going to start a recursive query of the top-level domain server for the internet. Now, that's called the root server. When a recursive request goes out from a name server, the responses are also called referrals, and those come back and are saved by the name server that made the request in the first place. The name server holds the location of everything it encounters along the way and all of the data in the answers that it receives, not just including the name and IP address resulting from your request, but also every name server that was helpful in coming to an answer. By holding the information about a request like www.apple.com, the name server that made the request learned where the com servers are. It learned where the Apple name server is, and it learned the IP address or CNAME redirection for the www server within that domain. It can easily provide another client the exact location of the www server, of course, but it can also shortcut any requests for other servers within the apple.com domain because it can go directly to the apple.com name server to find other names like store.apple.com without having to traverse the entire hierarchy from the root level down. They can do this because it cached the information about where the Apple name servers could be found. Caching-only DNS servers can be configured, if you wish, that contain no zone information, but which either forward requests to forwarder servers or which may be set as recursive name servers with no zone data. They simply make requests and cache response data to speed up the DNS resolution on your network by caching results of frequently encountered requests locally for your client systems.